Okay, good morning, everybody. We would like to welcome you to our presentation for the paper Fluid Manufacturing Systems, a novel approach for versatility in production. That's Christian Fries and Manuel Fechter, and we will present to you in session 1, next generation automotive production, our contribution 1.1.
Yeah, so very welcome from my side. So my name is Manuel Fechter, and I'm here today with Christian to present you the results. First of all, I want to start with the motivation definition. So what are we doing here and why are we doing this? So as you might know, so the product variants explode over the last decades, which you can see on the left-hand side. So we have definitely an increasing gap between the increasing number of variants and the more or less being steady production quantities. If you look on the right-hand side, you can see the different Golf model variants by Volkswagen with different duration of market availability. So what you can see, starting with the Golf 1 up to the Golf 6, the manufactured products are constantly decreasing, while at the same time, more or less the annual quantity being sold stays more or less the same. Looking at the different scope of changes required during a change from model year to facelift, relaunch, and to the overall change of product, we do look at different classification of alternative production systems. So if you look on the base side, usually what we see nowadays in manufacturing solution are the dedicated manufacturing lines. These can usually satisfactorily meet the required scope of one model product or 4 different variants, which we say can usually focus up to a model relaunch and then need excessive rework and reconsideration of design. Over the last years, there was this new variant of matrix production system, which first of all decouples production steps and products by flexibly linking the process modules. You may definitely have seen such systems which are flexibly linked by HEVs. What we propose into this paper is the use of fluid production system, which do extend the matrix production approach and fully and comprehensively use cyber-physical components inside the production system to accelerate the composition integration of process modules. If we look at the benchmark of alternative production system nowadays on market, you can see that there are more or less 4 main variants so far in use. As I already said, we do have the dedicated manufacturing lines, which do usually produce one model, one product with different variants at high volumes. Usually we have a sequential organization of dedicated workstation. That means we have technology, proper technology station, which follow up alongside a line. What was proposed in the past are flexible manufacturing systems. These usually have dedicated workstations which are capable of change their setup in a predefined scope of flexibility. But this flexibility has to be defined in advance during the stage of production planning. Corum proposed in the year 2010 concerning personalized production the use of reconfigurable manufacturing systems. This time, the flexibility corridors process modules can take up to is not predefined anymore. It's furthermore a defined stage of interfaces concerning hardware, software, and IT interfaces, which allow to reconfigure the production setup and the process modules to the use and the intention the manufacturing company wants them to use. By using this, we can set up multiple products in medium volumes on such a production system. Last but not least, and which is one of the newest appearances and approaches to manufacturing system design, is the matrix manufacturing systems, where we, as I already said, we try to break up the link in between the production cells and the production flow. Therefore, we can produce several products at medium volumes at the same time, and we do have a flexible organization. That means this is more or less a combination of the flexible manufacturing system approach with the flexible linking of the production cells. On the right-hand side, you can see like a chart of different hardware boards where we try to evaluate how well suited or not suited are the different manufacturing system approaches to different scores and ratings concerning different attributes for manufacturing and production system design. You will find a deeper explanation on this into our paper on the SCAP. Yeah, as I already said, these are mainly our motivations and definitions, and Christian will go on with the approach of the fluid manufacturing system implemented at Arena.
Thank you, Manuel, for the kind introduction. Let me tell you a little bit more about the background and results of our work. As Manuel already mentioned, one essential aspect of changeable production systems, and for the fluid manufacturing system in particular, is the sufficiently accurate mapping of objects from the physical world into the digital world. So the corresponding information and data models need to be developed and are required for the changeable production. And within our project at the Arena 2036, this is implemented with the so-called Industry 4.0 component. An Industry 4.0 component consists basically of an object that is surrounded by a digital administration shell, which you can see in the picture, called AAS. And the administration shell basically contains a self-description of the object and its capabilities, and therefore allows the virtualization and control of the component. The granularity of the AAS needs to be defined depending on the use case and basically the application and component itself. Basically, the AAS is a cyber-physical building block and is one cornerstone for changeable production systems with their changing production ranges, production resources, as well as the continuous reconfiguration with the need for fast ramp-ups. In order to understand the functional capabilities of production systems, we have distinguished three major module types. First, we look at the different process module types. So the dedicated process module, the DPM. The DPM has a predefined fixed functional scope, and DPMs are executing one single task at a time, whereby the functional changes are time-consuming and of high effort. Secondly, we can look at the dedicated technology models, DTM. DTM are capable to deliver a wide range of built-in functionalities while still requiring high efforts in resource and time consumption during the design and implementation phases. Third and last, we have the reconfigurable technology model, the RTM, which has a small functional scope, but a wide modularity. So therefore, the efforts for change are much lower due to the earlier described comprehensive use of CPPS during the process module design and implementation phases. So within the fluid manufacturing system, we mainly use reconfigurable technology modules in order to enable the fast ramp up and therefore production changes with low efforts. If we look at the comparison of different production systems, we can see that conventional production systems focus on the use of mainly dedicated process modules or the dedicated technology modules. And therefore, as you can see in the picture on your right-hand side, the system's response is time delayed compared to the according change request. The development of production systems from the dedicated manufacturing line, so from the left-hand side, towards the fluid manufacturing systems on the right, show an increase in changeability of the systems. So therefore, the time delay of systems responses has shortened further and further. The system response of fluid manufacturing systems runs smoother and therefore is not represented by box-shaped behaviors anymore. And it is following external triggers, for example, fluctuating demands or technical requirements smoothly. Accordingly, the gap between the red line, so the change request, and the black line, the system response, is getting closer and closer together. Overall, the FLMS allows for fast system responses with minimal non-productive downtimes. And therefore, we can conclude that the fluid manufacturing systems might leverage potentials regarding high production capacity, while at the same time having short changeover times. As seen before, the system's downtime caused by reconfiguration due to, for example, external trigger events is lower compared to other production systems. And therefore, the fluid manufacturing system ideally traces the system's demand curve, which is still and probably will be challenged by the volatile market environments in the future or changing product technologies. After all, the comprehensive use of CPPS, as earlier described, enables, for example, better fitting the functional scope of resources to the requirements. It also enables the avoidance of over-engineering in systems design and better adaptability to market demands. And also the faster production ramp up allows for the prevention of potential inefficiencies. The fluid manufacturing system, therefore, is a possible production system which encounters current and future challenges regarding new products, new technologies, increasing variance, as well as shorter development cycles.
Yeah, if we're looking into the future, we already gained quite a bit of overview of what fluid manufacturing system may look like, what are the benefits and what are also the drawbacks. What we try to do and investigate will be the organization, the architecture of FLMES in the future. So this might focus on the production planning and control itself. So as you might imagine, it's quite complex to control and plan a quite chaotic production system like the FLMS are, where nothing is predefined in the first place. This means especially controlling and optimizing the additional degrees of freedom, like operation sequence, like technology and process modules, and the quite accurate consideration and forecast of the different reconfiguration steps. We might also look into the requirements of the fluid manufacturing systems regarding the logistical processes and the interlinking of the process modules and material supply. So as you might imagine, it's quite difficult to predict where you want to build in a defined part when you don't know where it will be, in which step and which time. And last but not least, we also want to, which is one of the major points always asked by industrial companies, where is the profitability of the fluid manufacturing systems? And we want to investigate this using simulation studies and a quantification of risk and potential of the fluid manufacturing systems. So this is something we really want to focus over the next 3 years within our ARENA fluid production research projects, where we try to consider what is the sweet spot for fluid manufacturing systems within the scope of different and alternative production systems you can see on the left-hand side. And you want to compare and benchmark them. So thank you very much for the kind attention. Thank you also very much for our co-authors into this paper, which are highlighted here. And if you have any open questions, please leave a remark on the question app inside the Escape, the Escape conference module itself. And we're definitely looking forward to the discussion during the live session then on Monday, November the 9th. Thank you very much for your watching and for your kind attention.